Hello and welcome back to a brand new series on Serverless Hub, Azure Functions Next Steps. I hope you enjoyed and learned from our previous series, Building Web APIs with Azure Functions. The new series is going to be a sequel to the previous series. So if you are new to the channel, I suggest you check out the series, Building Web APIs with Azure Functions. I am your host, Nisal Wickramage. You can follow me on LinkedIn and GitHub. This series is focused on topics we didn't cover in the previous, which are essential for production-ready serverless applications. Let's get started. First episode of the series is going to be on unit testing. Unit testing is developers' best buddy when it comes to producing quality code. Azure functions are no exception. Unit testing will help us develop functions with confidence. Unit testing can be a daunting task if we don't consider a couple of key factors at the planning stage. First step in writing a pragmatic unit test suite is to identify the test boundaries. It is crucial that we choose a boundary that encapsulates majority of our code. This will help us get maximum coverage. It's important to select the correct test boundary so that the interfaces that our code communicate don't change much. Let's select the test boundary for the web API that we have in hand. We have two main components, the single page web app and the web API. We will not be discussing unit testing for the single page web app as it is out of scope. We will focus on the code that we deploy to the function app. We have a function app behind the API gateway which uses Azure Active Directory to authorize requests. Function app implements logic and the data is persisted into Cosmos DB. Let's consider the boundaries. API gateway and the function app is responsible for accepting HTTP requests and passing it to the Node.js runtime. Good boundary interface from the start of the workflow will be the request object and the context object. We will be creating mock objects to mimic the request from API management. We can use context object to validate output binding values set from the code. Next interface we need to mock is the Cosmos client in the Node.js SDK, which we use to query Cosmos DB. Once those two ends are covered, we should be able to start unit testing. We can handpick different libraries to build our own test framework. Next up is to select the test framework. There are many options. Azure documentation uses Jest test framework for testing functions written in JavaScript. We can use Jest for testing TypeScript functions as well, but we need a transform to transpile TypeScript into JavaScript. For this, we will be using Jest. Jest framework is backed by Facebook. It's fast and gives reliable results even when running in parallel. Jest includes mocks and coverage generation tools, so we will be using Jest for unit testing our functions. Let's get started by opening VS Code. This is the same code base that we developed in the previous series. Master branch of the repo contains the starting state. Add unit test demo branch will contain the state that we will achieve at the end of this episode. You can clone the code base from this repo. I will leave the URL in the description below. Let's start with moving the function code into src folder and creating a test folder for our unit tests. After shifting the files, we need to do a few changes to our configs here and there to make sure Azure functions can locally run and deploy to Azure. Let's create the src folder at the root. And we will move all the folders and the files which are related to the function app into the src folder. We will only leave the Visual Studio Code configurations, package.json, and the TypeScript configuration at the root. Now let's see if we can run our functions locally. Attempt to run the functions locally should fail. That is because we moved function app files into the src folder. Let's make few changes and make sure we can run the function app locally. Let's open the tsconfig.json. This is where we configure the TypeScript settings. Let's update the root directory and the output directory. After that, let's open up the VS Code settings. Open launch.json. We can see that the function host start task is called from the launch. Let's open up the tasks.json and let's modify the host start command. In this command, we need to specify the root folder. Let's mention src as the root. We need to update the launch.json with the same command. Let's try to debug. Press F5. Now VS Code should be able to run the functions locally. Let's verify if everything is in place. Let's ping the get to do items API. It can fetch data successfully. Finally, let's do another configuration change. This will make sure that we can deploy the function app from the SRC folder. Let's open settings.json and look for Azure Functions deploy subpath. Change it to SRC. Now we should be able to deploy from the SRC folder. Now that we have moved function app code into SRC folder, let's start setting up the test folder. As we discussed earlier, we will be using Jest framework for this. To use Jest framework with TypeScript, we need to install Jest types as well, along with TS Jest. Let's install the npm packages. We will be installing these packages as dev dependencies. Once the installation is complete, let's verify the package.json. We can see the new dev dependencies. Let's configure Jest. I will add a new file in the root named as jest.config.js. Here I will copy paste the configuration that is required. In the configuration, we specify the test folder as the root, and we need to specify test match. Jest will use this regular expression to filter out the test files. And finally, we will configure TS Jest as the transformer for our TypeScript files. Once we finish the configuration, let's create the test folder. And finally, we need to configure TypeScript to ignore the test files. Let's write our first unit test. I will create a test file. I will be naming the file as create_todoitems.test.ts because I will be using the same file to test the create_todoitems function. Don't have to add any Jest imports. We can use the Jest function test to write our tests. The first parameter will be the name for the test, and the second parameter is a function, which is our test. Let's write a dummy test. We will add 1 and 2 together, and we will assert the sum to be 3. We can do the assertion with the expect function. After adding the assert, let's run the tests. Let's go to the package.json and let's update the test command. We will just execute Jest, and Jest will know what files to run because we have already configured. Let's save package.json and go to the terminal. Let's run npm run test. Jest will execute the test and it will output the summary. Now let's write an actual test. First, let's go to create to do item function and see what's going on. As you can see, the function is called HTTP trigger and it takes two inputs, the context and the request. And the output record and the output response is also set to context. So to unit test this function, we will mock the context and the request, and after running the function, we will validate the context for output bindings and the response. Let's add a new test. Let's give a meaningful name for the test. And as the second parameter, let's add the test function. Notice that the test function is an async function because the function we are testing is an async function. Let's create a mock request. Mock request is going to be a simple object with body set to a to-do item. Next, we will need to mock the context object. Let's understand a bit more about the context object. Let's go back to the function that we are testing, create to-do item function. Context object is an implementation of the context interface, which is defined in the Azure Functions npm package. Let's create a mock implementation of the context interface. Let's create a mocks folder inside the test folder, and let's create the mock context. We will export a new class. Let's name the class as mock context. Let's implement the context interface. Let's add an import for the context interface. And let's implement the interface. Notice that VS Code will implement few properties and a single method. Let's update the done method. Let's remove the throw new error statement. And let's add mock implementation for log functions. We will mock error and info functions. These mock functions will be called from our function when we do logging. Next, we will implement the bindings property. It's going to be a simple object with to-do item record property in it. This will mock the output binding that we are using from the function. We will switch back to the test file. Let's create an instance from the mock context. And let's pass in the mock context and the mock request into our function. We expect the function to return HTTP status 2 or 1 if the validation passes. Let's add an asset statement for that. Let's run the test. Let's go back to the terminal and type in npm run test. The test will fail. Let's figure out why. We can see in the error messages, it is because of the getUserID method. The error message points to getUserID function in the utils. Let's open the function. As you can see, this function will read the request headers to validate the authorization token and get the user ID. In the mock request, we haven't added any headers. So there are two ways to go around this. One way is to add a mock authorization header. Other way is to mock the getUserID function. For this test, we will be mocking the getUserID function. Let's go back to the test and let's mock the getUserID function. There are many ways we can mock functions in Jest. For this particular function, we will use jest.spyon. To spy on this function, we need to specify the module and then the function name. Let's import the module. And let's specify the module and the function name. Once we set up the spy, we can mock the response from the getUserID function. Let's mock with the response mockUserID. Let's run the test again. This time it will execute successfully. Let's go back to the test. And add verifications for response body as well. Let's run the tests again. It should complete successfully. So if you notice, so far we have only verified the response. But to test this function completely, we need to verify output bindings as well. Let's do that. We can access the to-do item record output binding through mock_context.bindings. Let's verify the to-do item record properties. They should match with the request body. Let's run the tests again. Test should pass. So far we only tested the success path of our function. We will add a new test to verify the request validation. Let's add a new test. And let's give it a meaningful name. And let's implement the test function. Let's create a request with invalid to-do item. We will leave the description behind. And let's create a mock context. And let's call the create to do item function. For an invalid request, we are expecting HTTP status 400. Let's add an expect statement. Let's run the test again. It should pass. That will be all for the create to do items function. These two test cases will give us good coverage. Next, we will test the get to do items function. Let's create a new test file. We will name it get to do items.test.ts. Before writing any test, let's have a quick look at the get to do items function. Function name is going to be HTTP trigger, and it will take two parameters, context and the request. But there's a small difference. We are calling a get all to do items method. But there's a small difference. There's a get all to do items method. This method will give us an error which we will have to address shortly. Let's write the test. Let's give a meaningful name. Meaningful names are very important. Let's implement the test function. Again, it will be an async function because we are testing an async Azure function. Let's create a mock request. This time the request will be empty. We don't need to set any body properties. Let's create a mock context as well. And let's call the getToDoItems function. Remember, all HTTP functions will have the same name, HTTP trigger. When you are testing, be careful to import the correct HTTP trigger function. Successful outcome for this function will be HTTP status 200. Let's add an expect statement for that. Don't forget to mock the getUseID function. We will follow the same drill. We will be using Jest.spyon. Let's run the tests. As expected, it will fail. Let's figure out why. If you notice the stack trace, we can see that the error occurs in the toDoItems repository. That is because we are calling the getToDoItems function from the toDoItems repository from the main function. Let's navigate into the getAllToDoItems function. As you can see, we are creating free resource instances related to Cosmos DB. So when we are mocking this getAllToDoItems function, we need to create a complex mock object covering all these object structures. First, we are creating a Cosmos client which has the method database, which returns a database, and that database object will have a container method which will return a container object, and that container object has an items property which is another object with a query function, and that query function will return another object which has the fetchAll function. Let's go back to the test file and let's create the Cosmos client mock. To mock the Cosmos client, we will be using a different approach. We will be using Jest.mock. Jest.mock will allow us to mock entire node modules. Let's see how we can mock Cosmos client. First, we need to specify the npm package. Then we need to mock all the types and the functions that we will be using from this package. For our case, we are only using Cosmos client, so we only have to mock Cosmos client. If you are willing to learn more about Jest mocks, you can always refer the official documentation. I will add the URL for the documentation in the description box. Let's mock the Cosmos client constructor. It will return an object with a function database. Which will again return an object with the function container. And the container function will return another object which has the property items. And the items property is another object which has the function query. And the query function will return another object with the function fetchAll. If you don't quite understand the structure, you can go back and forth between the main function and the test file and understand it better. Finally, the fetchAll function will return the to-do item records. Let's add few dummy records. Make sure that the fetchAll will return the to-do item records in the correct structure. To-do item records are returned inside another object which has the resources property. Now let's run the tests again. It should run successfully. So we can confirm that our mocks are working. Let's add one more expect to verify the to-do item records. Let's verify if the correct number of to-do item records are returned in the response. Let's run the tests again. It should run successfully. Let's add another test. This will cover the scenario where we don't receive any to-do item records from the Cosmos DB. As always, let's name the function meaningfully. And let's implement the test function. Again, it will be a async function. Let's mock the request and the context and call the HTTP function. We will expect the response status to be 2 or 4. Before we run the test, we need to update the Cosmos client mock. If we go back to the get all to-do items in the to-do items repository, the to-do item records are filtered by the user ID. So we need to update our Cosmos client mock so it will return empty to-do item record set for certain user IDs. So after this update, mocks will only return to-do item records if the user ID is mock user ID. For everything else, it will return an empty set. We need to update the get user ID return value mock as well because get all to-do item function will filter to-do item records by user ID. Let's run the tests. It should run without any errors. Before we finish get to do items test, let's move out the Cosmos client mock object. We will create mock Cosmos clients file in the mocks folder and move the mock client there. Let's run the tests again just to verify that we haven't broken anything. So far we have tested 2 HTTP trigger functions. For a change, let's test a blob trigger function. The only blob trigger function in our project is the process uploads. We will create a test file for process uploads. Before writing any tests, let's take a quick peek at the process uploads function. One thing we can note is we are accessing a new property inside the context, So we need to add that property to the context mock. And the other change is, for each to-do item in the uploaded file, we are calling a create to-do item function from the to-do item repository. So we need to add that into the mocks as well. First change we can notice is in the parameters. For HTTP functions, the parameters was context and the request. For blob triggers, the parameters are context and the file blob. So we will need to create a file blob as well. Let's go to the mock Cosmos client and add a new function create inside the items object. Create function will take the parameter to do item record. And it will return the same to do item record inside the object with the property resources. Let's go to the mock context and add the name property to bind in data. We will add the name to do items.csv. And finally, we need to add the sample upload file. Let's create a new CSV file. Let's name it to do items.csv. I will be copy pasting few to do items. We need to do a small modification to the CSV file so that the function can process it. We need to add the user ID on top of the CSV file. Let's go back to the test file and write our test. Let's name the test. And let's implement the test function. We will create a mock context. The second parameter will be a file blob. So let's load the to-do item CSV into a buffer. Buffer is the equivalent data type in the node runtime. We will read the to-do item CSV using the read file sync function from the file system module. And we will use the join function from the path module to form the correct path. Let's load the to-do item CSV into a buffer. _dir name will get the current directory, and together with mock/to-do item CSV will give us the full path. Let's call the blob trigger function. We will pass in the mock context and the file blob. And let's mock the Cosmos client as well. I'll just copy it over from the previous test. Let's add the import statement. For upload test, we will be doing a small change. To make sure the blob trigger function works correctly, we need to make sure Cosmos client is called the correct number of times. For that, we need to replace the plain old JavaScript function with a Jest mock function. By using jest.mock class, we can get access to the mock Cosmos client instance. This will be useful when we are going to assert Cosmos client is called correct number of times. Let's run the test. As we discussed in the beginning of the video, Jest has built-in coverage report functionality. Before we wrap up this topic, let's see how we can generate coverage report. Let's open up the package.json and let's specify the parameter collect coverage. Let's run the tests. As you can see, now it will generate a coverage report for us. And if you notice, we created tests for create to do item, get to do items, and process uploads. All of them has 100% coverage. So we have done a good job. And if you need to push the coverage report into a dashboard such as SonarQube, you can use the reports generated by Jest under the coverage folder. With that, we conclude this video. This is the first episode of the new series, Azure Functions Next Steps. I am your host, Nisal Wickramage. You can follow me on LinkedIn and GitHub. And if you find this episode useful, please like and share with your friends. And subscribe to Serverless Hub if you haven't already. Stay safe and thank you.